it's time we look at the graph of the tangent function. Now the tangent, as you should already be well aware, is the ratio of the sine over the cosine. Okay? So when I ask to see the tangent unto itself, okay, or the sine over the cosine, they're one and the same. Okay? They're one and the same. There they are, one and the same. Now, the thing that's going to hit us here is all these periodic asymptotes. All these periodic asymptotes. Okay? Now, why do they occur? Well, they occur because the ratio of sine over the cosine, we need to be concerned about when the cosine becomes zero. Because look, wherever the cosine becomes zero, okay, wherever the cosine becomes zero is where we're having all our periodic asymptotes, okay? Because division by zero is undefined. So, here's all our asymptotes for the tangent graph. They occur, okay, with this regularity, okay, every pi radian apart, starting at pi over 2. So pi over 2 plus pi is 3 pi over 2, plus another pi is 5 pi over 2. Pi over 2 minus pi value is negative pi over 2. So we find that the tangent has these periodic asymptotes occurring, okay, wherever the cosine function has its intercepts. Let me repeat that. Wherever the cosine function has its intercepts, the tangent function has its asymptotes. And wherever the tangent function has its asymptotes, okay, is where the function is undefined and therefore are breaks within the graph of the tangent, within the domain of the tangent. So, unlike our friends that we looked at with the sine and cosine, okay, sine having a complete uninterrupted domain, okay, but a very limited range, okay, when we look at tangent, and specifically as the concern of the cosine function, we find that the tangent does not have an interrupted domain. It has a constantly interrupted domain, and the interruptions occur wherever the asymptotes occur, which are at these values where the cosine becomes zero. Okay? Also, the tangent function, as we can see, okay, is going to have the range which is running from positive to negative infinity. Okay? This is an asymptote, meaning it's heading for infinity. The graph is riding along that asymptote. Okay? So we'll also see that the tangent, the frequency of the reappearance of the tangent, is having a period of pi. If we go from here, the next cycle comes over here, which is at pi units down the line, which is again asking us, well, what are the intercepts of the tangent? Okay, well, here are the intercepts of the tangent. And perhaps asking where the intercepts of the tangent, perhaps we should look at the sine and cosine and ask ourselves, well, okay, if it's the sine over cosine, then we have to be concerned um, where the sine is zero and the cosine is not. Well, the sine is zero, okay, at values here of 0, then of course at pi, then of course, okay, down here later at 2 pi. So, so where the sine is 0 is where the tangent is going to have its intercepts, okay? So, where the sine is 0 is where the tangent has its intercepts. Where the sine is 0 is where the tangent has its intercepts, okay? Where the cosine is 0, where the cosine is 0 is where the tangent has its asymptotes, okay? Now we're just going to close by taking a list of some of the properties of the tangent, and I will provide you with this list for your reference, okay? As we said, the tangent is defined as the sine over the cosine. So that ratio is going to be undefined whenever the denominator goes to 0, which is where the cosine becomes 0. And the cosine becomes 0 at all values pi over 2 plus pi k. Therefore, that is where the tangent is undefined, and apparently, therefore, where it has its asymptotes. And also, as we'll mention down here later, is where the domain is undefined. Okay, so again, the denominator is the cosine, where cosine goes to 0 is pi over 2 plus pi k. That's where the asymptotes of the tangent function occur, and that's the hold up values in the domain of the tangent function. Okay, so it is easier to say what the domain is not rather than what it is. So we could say the domain is all real numbers except all values of the variable satisfying pi over 2 plus pi k, or else we could say the tangent is everything is undefined at pi over 2 plus pi k. Additionally, we had said, since tangent is that ratio of sine over cosine, where the sine becomes 0, are the values coincident with where the intercepts or where the tangent becomes 0. Okay, so since the sine goes to 0 at all multiples of pi, we make the conclusion that the tangent has its intercepts at all multiples of pi. Okay, we have these periodic asymptotes as stated. Okay, and we also find that unlike the sine and cosine, the period is pi. Okay, the period is pi. All right. So the tangent of the period of the tangent is pi, not 2 pi over, as it is for sine or cosine. Okay. What else do we note? We note that the tangent has some degree of symmetry. Okay, here we are. It has the same symmetry, okay, as the sine function does. Okay, it has the same symmetry as the sine function does. That is, it's symmetric about the origin. It's symmetric about the origin. Okay, and this is our statement of symmetry here, that the tangent of the negative angle is the negative tangent of the angle. We also note that the tangent is forever increasing, and that is to say that as you proceed on the function from left to right, all these branches are always going uphill, meaning increasing. So that's another feature of the tangent. Okay, is that it's always increasing. Okay, and as mentioned, the range is wide open from negative to positive infinity, but the domain is constantly interrupted with these periodic asymptotes occurring at pi over 2 and pi plus pi k. So a lot can be learned here by definition of the tangent as the sine over the cosine, and you know, Desmos allows us to explore these features quite readily, and that's basically, I'm going to let you explore with Desmos with some guidelines with a sheet that I'm going to provide you. The other trig functions, okay, mainly the secant, cosecant, and cotangent. Okay, so that will be an exploration process that you will have with Desmos and a guided questionnaire from which these type of responses will be your answers. So think about listing these kind of things, these kind of questions in terms of domain and range, in terms of asymptotes and intercepts that will be asked of you for questions regarding secant, cosecant, and cotangent. Okay, and that should do it for now.